Hi everyone. Welcome to Solving Specific Heat Questions in Regents Chemistry with Mr. Aldrich. For this video, you are welcome to print off the handout which is provided, or you can follow along and pause the video as we move through slides to write down the questions. Let's start with example 1. I'd like you to just listen to me for this example, so please put your pencil down and just follow along up on screen. This question asks us, how much energy is required to raise the temperature of 15 grams of liquid water by 5 degrees Celsius if the specific heat of water is 4.18 joules per gram times degrees Celsius? First, we're going to write down the values that we know and the values that we don't know. I don't know the energy, so that's what I'm looking for. I'm going to put a question mark here. I do know my mass, which is 15 grams, C, which is 4.18 joules per gram degrees Celsius, and delta T, which is 5 degrees Celsius. Next, I'm going to look here to my specific heat equation, Q equals mc delta T. I'm going to substitute in my known values, and then I'll get out my calculator, and you all should have a calculator for this. We'll type in our values to our calculator, and if we multiply these three values together, we get Q equals 313.5 joules. Okay, let's move to example 2. Go ahead and pick up your pencil for this one, and let's do this one together. So example 2 says, how much will the temperature of an 8-gram sample of iron change if it absorbs 100 joules of energy, and we're given that the specific heat of iron is 0.45 joules per gram degree Celsius? What should we do first here? That's right. Let's write down a list of the things that we know and that we don't know. After that, what should we do? Good. Let's substitute our known values into the specific heat equation, Q equals mc delta T. So I'm going to go ahead and sub those in. I'll leave delta T in place because that's what I don't know. And then what should we do? That's right, we'll just do some math and we'll solve for delta T. When we do that, we find that delta T equals 27.8 degrees Celsius. Let's move on to example 3. Example 3 is on the board here and you have it on your paper. What I'd like you to do right now is turn to your partner who's next to you or in front or behind you. Okay? Work with your partner and let's see if you two can solve this question on your own. Go ahead and pause the video now and we'll go over the answer in just a moment. Okay, hopefully you and your partner have been able to work through example 3. First, we should have made a list of the things that we know and we don't know, just like this. After that, I hope we plugged our values into the specific heat equation and we calculated the value of M to be 243.6 grams. Did you all get that? Okay, I hope so. Let's move on to example 4. I'd like you to try example 4 on your own, okay? No partner this time. Let's see how you do. Again, go ahead and pause the video and see what you can do. Okay, hopefully you were able to work through example 4 on your own. So first we make a list of the values that we know and that we don't know. We find that we're looking for delta T in this question. We plug our known values into our equation. And finally, we calculate and solve for delta T, which in this case was 78.1 degrees Celsius. Last question here. Okay, we've got example 5 here. Again, go ahead and pause the video and try example 5 on your own. This time, I'm only going to give you the answer. So let's see if you can come up with the work for this on your own. All right, hopefully you were able to work through example 5. If you did it correctly, we should have found that you simply multiply all the given pieces of information together and arrive at Q equals 807.5 joules. This has been solving specific heat questions with Mr. Aldrich, and I hope that was helpful.